Chandrayaan 2 is the second lunar exploration mission of the Indian Space Research Organization ISRO. It is an ambitious follow up to the successful Chandrayaan 1 mission, which was India's first lunar mission and was launched in 2008. Chandrayaan 2 was designed to build upon the knowledge and data acquired during the Chandrayaan 1 mission and to further explore the moon's surface and its composition. Chandrayaan 2 was launched on July 22, 2019 from the Satish Dhawan Space Center in Sriharikota, India. The primary objective of the mission's orbiter is to study and map the lunar surface, lunar exosphere, and help to create detailed 3D maps of the moon's topography and mineral distribution. The lander was known as Vikram lander. Its objective was to make a soft landing on the lunar surface near the South Pole and to conduct various scientific experiments. The rover was named as Pargyan rover. The rover was designed to operate on the lunar surface, analyze soil samples, and transmit data back to the Earth. But unfortunately, the Vikram lander did not achieve a successful soft landing on the moon as planned. It lost communication with mission control during its descent in September 2019. As a result, the Pargyan rover was unable to be deployed. While the lander and rover faced challenges, the orbiter successfully entered lunar orbit and continues to operate. Question arises, why Chandrayaan 2 fails? Chandrayaan's 2 mission to soft land on the moon's surface did not go as planned, and the lander encountered difficulties leading to its failure. The primary reason for the failure can be attributed to a combination of technical and communication issues. Here are some key facts that contributed to the failure of landing. First was communication loss. It was supposed to touch down on the lunar surface. This loss of communication prevented real-time monitoring and control of the landing process. Next was the navigation and guidance challenges. The landing process involves a series of complex activities, including reducing the lander's velocity and aligning it with the landing site. Any deviation from the planned trajectory can lead to landing failure. It's possible that navigation or guidance systems encountered issues during descent. Third challenge was altitude anomaly. Reports from ISRO indicated that lander experienced an altitude anomaly, meaning it deviated from its expected descent path and altitude profile. This could have been caused by a variety of factors such as sensor readings or software errors. Next challenge were rough terrain. The chosen landing site for Chandrayaan 2 near the lunar south pole presented a challenging and uneven path with large boulders and craters. Landing in such terrain requires precise controls and adjustments, and any misjudgment can lead to a landing failure. Fifth challenge were time constraints. The descent phase is time sensitive and corrections must be made quickly if any issue arises. If the lander encountered a problem and failed to respond in a timely manner, it could result in a crash landing. The sixth challenge was software glitch. Software plays a critical role in controlling the descent and landing process. A software glitch or anomaly could have disrupted the planned sequence of events and contributed to the failure. But it's important to note that space missions, especially those involving complex activities like lunar landings, are inherently challenging, and even a small error can lead to mission failure. Despite the failure of the Vikram lander to make a successful soft landing, the Chandrayaan 2 mission's orbiter has continued to operate successfully and has provided valuable scientific data about the moon's surface and environment. Lessons learned from this mission are the reason to make Chandrayaan 3 most successful lunar mission by ISRO. On 14 July 2023, Chandrayaan 3 mission is launched by ISRO for soft landing on the moon. Chandrayaan 3 is launched to fulfill those objectives which were not done by Chandrayaan 2. Landing area is made wider. Chandrayaan 2 had to land in just the patch of 500 meter by 500 meter, but for Chandrayaan 3 the area of 4 kilometer by 2.4 kilometer is covered. More fuel is given to Vikram lander so that it could suspend in atmosphere and could find the correct landing site. Softwares are updated so that lander can spin fastly. At this time, lander is not just limited to take photos. Chandrayaan 2 mission is called as half successful mission because its orbiter is still working. The high resolution images taken by Chandrayaan 2 are saved in this new lander so that it can decide correct and fair landing locations. Chandrayaan 3 Vikram is the modified form of Chandrayaan 2, but more solar cells and sensors are installed into it. The purpose of Chandrayaan 3 is also landing on the south pole of moon and to place a rover. Now the landing location is 70 degrees south where large numbers of craters are present. This has always remained in shade so that it is considered that ice is present in these craters. When rover is placed over moon, then it has to perform all the experiments in just one lunar day. One lunar day equals to 1 month of the earth, which means 14 earth days and 14 earth nights. As the moon orbits the earth, so it also makes one complete revolution about its axis. This unique relationship results in the same side of the moon always facing the earth. The instrument present in Chandrayaan 3 can't perform in lunar nights because in lunar night temperature goes down even up to minus 232 degrees Celsius. In such cold environment, any operators can't do any experiment. That's why ISRO chief has said that if we want its landing, then sun should be rising on the moon. Since that we will have a period of 14-15 days to work and collect data. And if landing would fail on 23rd 24th August, then we will wait for a month and will do in September, but fortunately it's done. Vikram lander weighs 1750 kg and rover weighs 26 kg. The rover name is still Pargyan rover. There are three modules of Chandrayaan 3. First is propulsion module, second is rover module, and the third is lander module. With the help of propulsion module, lander and rover will be welcomed to moon's orbit and will be placed for landing in the radius of 100 km. There is no orbiter module in this mission because rover of Chandrayaan 2 is yet working and will be used in this project. Propulsion module will revolve around the moon for 3 to 6 months. It will be used for communication purposes and for taking other readings. An instrument fixed in propulsion module named as spectropolarimetry of habitable planets Earth, in short form it is called as SHAPE. SHAPE will search for small exoplanets in space. Rover. Now the Pargyan rover has two instruments. First is LIBS, which stands for Laser Induced Breakdown Spectroscopy. It will analyze the chemical composition of lunar soil and will find out the materials present in lunar soil. Next is Alpha Particle X-ray Spectrometer. In short form, it is called as APXS. It will analyze stones on the moon. Vikram lander has four instruments. First is RAMPA, which stands for Radio Anatomy of Moon-Bound Hypersensitive Ionosphere and Atmosphere. It will try to melt some small stones on the moon through a laser beam and will analyze the gas released from it. Second is CHAST, which stands for Chandra's Surface Thermophysical Experiment. It will measure thermal properties. Next is ILSA, which stands for Instrument for Lunar Seismic Activity. It will measure the moonquakes. Fourth is LRA, which stands for Laser Retroreflector Array. It will use laser to bounce signals from the Earth. With the help of LRA, scientists could measure the exact landing distance of Vikram lander and moon's range. There are total 7 instruments, also known as 7 payloads. If that mission would be successful, then India will be fourth country in the world that will make the history of soft landing on the moon after America, China and Soviet Union.